What's Gucci, everybody? It's AJ again, and in this video I want to talk about how to insert into a 2, 3, 4 tree. Now, if you haven't watched my last video where I introduced 2, 3, 4 trees, please watch it as it sets the rules and boundaries for how to make a 2, 3, 4 tree. In the next two videos, I hope to be covering how to insert and how to delete from a 2, 3, 4 tree. Now, to insert, you actually have to follow a few rules that kind of can be complicated, just really one rule, and this allows the tree to always be balanced and always not be like a binary tree, like I said, and somehow devolve or deteriorate to linear time. So, as you can see here, I have a 2, 3, 4 tree. Very similar, probably exactly to the example I used in the last video. And now I'm going to show you how to insert. Now, I'm going to show you how to insert 60. And what I'm going to show you is I'm going to show you the algorithm and the rules for it. So I have it actually typed up here already. Whatever you want to do is you want to go through the tree in the order looking at the arrangements that you have to look at, but then whenever you start at the root, and then whenever you counter a 3-key node, you take the middle key and you place it in the parent node. Now, if the root is a 3-key node, like in this example, you make a new root, which is just one node, and you make the other two nodes child nodes. You make the other two values child nodes. Let me show you what I mean here. So I'm going to insert 6. Gosh, that scared me. I'm going to insert 60, and I'm going to start at the root. So I start right here, and I see that I have encountered a 3-key node. So what I'm going to do is I'm going to push the middle key up, which is 40. Now that means 40 is going to be the new root. So I'm going to make 40 the new root. And now what I need here is I need to have children for each of these 3 nodes to still go to. So 40 is the new root, and then I'm going to make this 20, and I'm going to make this 50. So 20 and 50 become the childs of 40, which I pushed up. And now I have still I'm still following the rules of the tree. It still has one value, except I basically made one node into 3 nodes. So now again I'm at 40, then I go to 50, then 60 is greater than 50, so I go to the right node of 50, and now I've ran to 70 and 79. So I know 60 is less. I look at this and say 60 is less than 79, so I go here, and now I run into another 3 node. So what I do here is I'm going to push up 57. I'm going to push up 62, which is the middle node, into those values. So here we go. I'm going to push up 62, and we're going to have 70 here, and we're going to have 79. And, oh, God, I forgot what the last value was. What was it? Okay, it was 65. Sorry. So, yeah, again, I push up 65. I should just do it this way. Push up 65. 62. My bad. And I've got 70. And now that I've got those, what I'm going to do is, since now I have a 3-key node, the 3-key node now has to have the node with 3 entries has to have 4 nodes. So I break this node up. I make 65 into its own node and 57 into its own node. And 57 represents the values less than 62, and 65 represents the values between 62 and 70. And now that I have those connecting to that node, what I can do now is I see that 60 is less than 62, and I'm at 57. And what I can do here is I'll draw this a little bit lower. I can see that I can now do 57 and add it to 60, because I'm now not running into any more 3 nodes, because as I need to fix the 3 node, and then I can continue going down, and this allows me to still preserve the balance of the tree, which is great. As you know, as you saw, I created some other nodes, but I didn't make another level in the tree or another height. I was able to preserve that because I was able to rebalance the tree. Now, if all of them were 3 nodes, you would create a new level. Also, another thing I want to add is that let's say you are inserting a duplicate. So I'm inserting 60, but 60 has already been inserted into the tree. That is not a problem, and the rule for that is if you walk down the tree in search of K, if you find K, you proceed to K's left child. So if I found 60 here, if I found 60 here, I would go to the left child. And that is the left child relative to K. So let me say in this example, if I had 60, this is a better example. If 60 was between 54 and 51, the left child of 60 would be 54. It's relative to where that node is. So it would be the node of 54. And that's where you would go. Or you would proceed to K's left child, which would be, again, like I said, which would be this child, not this child, not this child. So it's relative to where the value is. So the left child of 60, this is the right child of 60, and that's the left child of 60. So yes, point an arrow to it. So that's how you insert nodes in a 2, 3, 4 tree. You basically, if you encounter a 3 node, you take the middle value and you move it up, making changes as you go along. Well, guys, I hope this video made sense. Please subscribe if you want to, and have a great day. Please comment and tell me if you think this video sucks or it's awesome. And that's about it. Have a great day.